Hello everybody and welcome to Learning at Home with Mrs. V. Sorry for the close-up, but today we're actually going to be working on a paper, and so I have it zoomed in, and so let's get started. All right, so first of all, I'm going to tell you what we're going to be working on today. We are going to work on equivalent ratios, and we've talked about equivalent ratios before, but today we're going to find the relationship with those equivalent ratios and use that relationship to continue the table. All right, so we're going to be looking for those patterns and putting those patterns together to find the equivalent ratios to complete the ratio table. All right, so for the first problem, it says here, to make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix 3 cups of flour to make the paste. Find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent fractions, or the equivalent ratios, ratios in the table below. Well, remember yesterday we were working on ratios and we also wrote them as fractions. So I think that's why my brain went to that. All right, so right away I see my ratio language. I've got for every, so I've got some ratio language there. And I forgot to mention, you need to write these down because I'm going to ask you to fill these in. The ones that we do together will be a piece of cake. It'll just be extra practice. And then you're going to have the problem set to work on then on your own. All right, so we've got for every 2 cups of water, we need 3 cups of flour to make the paste. So we've got 2 to 3. So 2 cups of water, 2 for every 3. All right. So we've got our original ratio, and we could write that out to the side, 2 to 3. Remember, we can also write it 2 to 3. All right. So we've got 2 to 3. So if I wanted to make 2 batches of that paste. Sorry, my brain went to mush for a second there. I would have 4 cups of water. Now, how is that going to change the cups of flour? I want to keep this 2 to 3 ratio. So if I'm creating this and I've got 2, I know that I'm going up by 2 here. How many am I going to go up here? Well, I'm counting by 3s. So 3, it would be 6. Okay, so what if I wanted to make another batch? How much am I going to have? Remember, I'm going to keep this 2 to 3 ratio. So I'm counting by 2s here, so this would be 6. I'm counting by 3s, 3, 6, 9. All right, I'm continuing that 2 to 3 ratio. All right, so I want to continue this ratio, the 2 to 3 ratio. So what's going to come next? Well, if you said 8 to 12, you are correct. I want to continue the pattern, continue the 2 to 3 ratio, then I would have 10 to 15. All right, so let's take a look at this information. And what does 2 to 3, what does that mean? Well, it means for every time that we have a set of 2 cups of water, we also need a set of 3 cups of flour. Why do we word it for every? Well, then this suggests or tells us that we need to repeat that, the 2 cups for every 3 cups of flour each time we make another batch. Okay, so when we go to 4 cups of water, there are 6 cups of flour. So when we look at that, does that continue the 2 to 3 ratio? Well, yes, it does, because we're continuing the pattern that we've created here. So we go up 2. So for every 2 cups, when we add another 2 cups, we have to add 3 cups of flour. So we're continuing that 2 to 3 ratio pattern all the way through the ratio table. All right, so let's take a look at another example and another table. All right, so this is example 2. Let me go ahead and put that up here. Got example 2, and all of these will be on your Google Classroom underneath this video. All right, so this time we have Javier, and Javier has a new job designing websites. He is paid at the rate of $700 for every 3 pages of web content that he builds. Create a ratio table to show the total amount of money Javier has earned in a ratio to the number of pages he has built. So we're going to look at this information first and fill in the table. All right, so I noticed that here it says for every. So for every, again, that tells me ratio language. So that gives me an idea of what I need to do. Okay, so $700 per 3 pages, or for every 3 pages. So total number of pages. So if he does 3 pages, he earns $700. Okay, now I have to continue that pattern. So now, in order for him to earn his next unit of money, we would do 6 pages, 3, 6. So how much money then would he earn? Well, he would earn then another $700. So 700 plus 700, or 700 times 2, would be $1,400. So what would my next unit be when I'm counting up? So I'm counting 3, 6, so I'm counting by 3s. So 3, 6, so 9 would be the next number of pages. And then instead, if we come back here, this would be 3 units. So 3 units would be 7 times 3, which is 21, and that would be 2,100. Or I could have looked at it this way and looked at the 1,400 and added another 700 to it to get the 2,100. So now I've got to continue my pattern, continue my ratio. So I've got 3, 6, 9, we've got 12. If he builds 12 pages, web pages, then he would have an additional $700 that he would earn. So we could add the 700 to this, and I'm looking here, if I look at this, this is counting by 7s. Well, 700s, but I have to add the zeros on the end, but it is counting by 7. 7, 14, 21. Well, the next 7 would be 28. And it wouldn't be just 28, it would be 2,800. Aha, I like making it simple. All right, so we've got 3, 6, 9, 12, 15. 15 web pages. Then he would earn an additional 700, which 1, 2, 3, 4, 5 7s would be 35, and it wouldn't be just 35, it would be 3,500. All right, 3, 6, 9, 12, 15, 18. All right, so we've got 6, 1, 2, 3, 4, 5, 6 this time. So 6 7s would be 42, and then it would be 4,200 because we're counting by 700s, not 7. Even though we can use 7 as a basic pattern. So 18, so 21 would be next. So we've got 7 700s, which would be 4,900, because it would be adding an additional 700 here. We've got to continue that pattern, continue the ratio. All right, so the next one would be 24 pages. That would be 8, and 8 times 700 would be 5,600. All right, so let's take a look at the question that they're asking now. Javier is saving up to purchase a used car that costs $4,200. How many web pages will Javier need to build before he can pay for the car? So let's go back up to our ratio table. How many web pages did we say that he needed to create in order to make $4,200? Well, I notice here 4,200 is right here, so he would have to create, so Javier would need to create 18 web pages to pay for the car. Okay, and we found that information right here in the ratio table. All right. All right, and if we go back to the beginning of this, remember we can always take a look at these as ratios. So we could write this ratio as 3 web pages for every $700, 3 to 700. All right. So those were our first 2 examples. Now let's take a look at this first exercise. I kind of like these. These are things that could, well, at least I know there are a few of you who last year talked about gardening when you were doing your Earth Day activity for me. So this might be something that would be relevant to you. Okay, spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table to answer the questions that follow. Okay, so we're looking for our ratio language. Here it is, for every. It's important to find that and to identify it. So we've got 2 cups of cornmeal for every 9 gallons of water. So 2 to 9. So the cornmeal comes first. So the 2 would be the cornmeal and the water would be the 9 gallons. So we can go ahead and write that in here, 2 to 9. All right, well, let's continue the pattern. So if we want to make, so this is 1 container of the plant spray. So what if I wanted to make 2 containers of the plant spray? Well, I would need 4 cups of cornmeal and I would need 18 gallons of water. Okay, that right there is equivalent to 2 to 9. How do I know? I multiply times 2 on this side to get the 4. I multiply times 2 on this side to get the 18. So I'm continuing that pattern. It's just the same as what we did with equivalent fractions. All right, let's continue the pattern. So if we come down here, it would be 2, 4. This would be 6. And this would be 9, 18, 27. So how did I how did I create this equivalent ratio? Well, this time I multiplied times 3 to both sides, just like we do with equivalent fractions. Let's continue the pattern. 2, 4, 6, 8. 9, 18, 27, this would be 36. How did we get this equivalent ratio? Well, this time we multiplied times 4 to both sides. All right, 2 times 4 is 8, 9 times 4 is 36. Let's continue the pattern. This would be 10, this would be 36, so we've got 1, 2, 3, 4, 5 would be 45. 10 to 45. All right, so we've got, for every 10 cups of cornmeal, we have 45 gallons of water. So 2 times 5 is 10, 9 times 5 is 45. So we continued the pattern. All right, so let's go ahead and answer these questions. How many cups of cornmeal should be added to 45 gallons of water? Well, we've got the 45 gallons of water, so we need, you need to add, and then we go back up here, it says cornmeal. So we need to add 10 cups of cornmeal, okay? And we have that right here in the ratio table. All right, so let's take a look at the next question. Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? So we've got 8 cups of cornmeal. So I'm going to go up to my ratio table. 8 cups of cornmeal. How much water does he need? It says right here, 36. So Paul needs 36 gallons of water. All right, my last question. What can you say about the values of the ratios in the table? Well, we know that the values of these ratios, and we talked about them as we went along. All we were doing was we were continuing the pattern. So the ratios are all equivalent. And we can prove that by going up and identifying the pattern that we are continuing. Okay? All right, one last exercise that we're going to do before you are going to do some on your own. Remember, all of these need to be filled in, so I'm hoping that you're writing all of these down. Okay, so there was somebody who met with me on my Google Meet last snow day who introduced me to his pets, and he had fish in his fish tank. And so this problem is making me think of that person. All right, you know who you are. James is setting up a fish tank. He is buying a breed of goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown goldfish in the tank? All right, so we are going to be talking about goldfish. And if we have 1 fish, we need 12 gallons of water. So it says it is recommended that there be 1 gallon for every inch. So if the goldfish is 12 inches long, okay, then we need 12 gallons of water. So if one fish is 12 inches long, we need 12 gallons of water. So 1 to 12. Now it says fully grown. That's how I know that. That fully grown is very important. Okay, so it says here that he's 12 inches long. We put him in the tank. We need to have 1 gallon of water for every inch he is long. So if he's 12 inches long, we need 12 gallons of water. Okay, does that make sense? All right, if you have questions about that, I will have office hours later on. Okay, so what if there are 2 goldfish? How many gallons of water will I need? I need to continue the pattern. Remember, my pattern was 1 to 12. So this would be 24. So I take this and I multiply the 1 times 2 to get 2, and the 12 times 2 to get 24. So what if there were 3 fish in the tank? That sounds familiar. The someone I was talking about, I think there were 3 fish in his tank. All right, so 12 times 3 then is 36. I'm continuing the pattern. I'm just marking equivalent ratios. So now I have 4 fish in the tank. 1 times 4 is 4. 12 times 4 is 48. What if I had 5 fish in the tank? 5 times 1 is 5. 12 times 5 is 60. All right, so what size tank in gallons is needed for James to have 5 fully grown goldfish? Well, I can go back to this ratio table, and I can see that if he has 5 fully grown goldfish, he needs a 60-gallon tank. So James will need a 60-gallon tank. All right, how many fully grown goldfish can you get in a 40-gallon tank? Oh my, 40 is not in there. So how are we going to figure 40 here? So if he has a 40-gallon tank, how many goldfish can he put in that 40-gallon tank? Well, if I go up here, 40 is in between the 36 and the 48. So he wouldn't be able to put 4 goldfish in there because the tank would be too small. So he would only be able to get 3 goldfish in a 40-gallon tank. James can put 3 goldfish in a 40-gallon tank. Okay, what can you say about the values of the ratios in this table? Well, all of these ratios, remember I multiplied times 2 times 2 times 3 times 3 times 4 times 4. That sounds a lot like equivalent fractions. So what can we say about these ratios? These ratios are all equivalent. All right? So, in closing, when creating a ratio table, each pair of values represents a ratio that is equivalent to all the other ratios in the table and describes the ratio relationships in their quantities. So, I want you to do some of these on your own, and remember that we are creating equivalent ratios. We are finding the relationship between the numbers, continuing that pattern, and then answering questions about those. So your problem set looks like this. This is what I want you to work on. I want you to look for the patterns and then fill in the values that are missing. All right? If you have any questions, I have office hours from 1 to 1:45. The only thing that I require is that you come in comfortable slippers and bring a hot cup of cocoa. No, I'm just kidding. But you can bring your slippers and cocoa. That's fine. Also bring your questions. So if you have specific questions for me, then you can ask those at that time. All right, I want you to keep watching, keep thinking, always stay curious. I'll see you next time. No, I hope I'll see you at 1 o'clock.